Just wanted to run through a few of the lots of power rule practice problems here just to give you a few extra examples. Oop, there goes a little beep there. Maybe I should shut the volume off on that thing. Okay, so the deal on this first row here, 1 over x squared, 4 over x cubed, and 7 over x to the 6th is, before we do the derivative, what we're going to do is rewrite the original function using negative exponents, because we want to use the power rule to do this. So I'm going to rewrite 1 over x squared as x to the negative 2. Once I do that, my derivative, y prime, is just going to be negative 2x to the negative 3. Remember, we subtract 1 from negative 2 to get negative 3. And then typically what we do is we rewrite that answer without the negative exponent. So my final answer would be y prime equals negative 2 over x to the negative 3. Over x cubed. The whole point was to get rid of that negative. So in terms of simplified form here, we typically write the problem like this in the green highlight. And you can just crank out the rest of these in a very similar way. I rewrite y equals 4 over x cubed as 4x to the negative 3. And then as I do the power rule here in red, I get y prime equals, what, negative 12x to the negative 4. And then finally write that answer as y prime equals negative 12 over x to the 4th. And I'll highlight that in green again. That's our derivative function. And finally, we'll finish out this row. You know I'm going to rewrite this as y equals 7x to the negative 6. When I do the derivative, y prime will get negative, 6 times 7 is 42, x to the negative 7, because negative 6 minus 1 is negative 7. And then we'll rewrite it in that final form of negative 42 over x to the 7th. In case you're wondering why I decided to write it in this final form, my recommendation is whatever the problem originally looks like, that's the form you want to try and keep it in. So we were given it as 7 over x to the 6th. I'm trying to answer it as, that's y prime, sorry. This is the derivative, y prime, negative 42 over x to the 7th. Now, you handle 28 through 30 in a different way, because these functions are do not include negative exponents. So when I rewrite this, I'm going to write it as a constant multiple. This is actually just 1/2 times x squared. So I write it that way first, and then when I do that derivative, y prime, that's going to be 1/2 times 2x, right, because I bring the power down, which turns out to be just x. And so the final derivative form for that one is just x. The derivative of x squared over 2 is just x. And I'm going to, 29 and 30, I'm going to attack the same way. I'll rewrite it as 1/4 x to the 4th. And then when I write that derivative, it's just y prime equals, 4 times 1/4 is 1, so that's just 1. I won't write it. And then x cubed, because 4 minus 1 is 3. So that one's y prime equals x cubed. Oops, I highlighted in blue. That's fine. And then when I rewrite this one as 1/6 x to the 12th, when I bring that 12 down multiplied by the 6, that's actually a 2. So this is going to be 2x to the 11th. 12 minus 1 is still 11. Let's see if I can get that highlighter in green this time. There it is. Okay, and then let's go through 31 through 33 just to remind you. So on this one, notice the fractions get a little more complicated. I rewrite this in blue usually as, oh goodness, now I'm all messed up. Let's just start this whole thing over. Okay, let me do a blue pen here like I did in the other ones. So I'm going to rewrite this as a constant multiple 2/3 times x to the negative 2, which is the power of x. Now when you do that, you bring your power down. That'd be negative, oh goodness. Having one of those moments here. This video is going downhill quickly. Negative 2 times 2/3 is negative 4/3 for that derivative, the coefficient out there. and then the power of x goes to negative 3, because negative 2 minus 1 is negative 3. So when I write this final derivative form, I'm going to have y prime equals. The negative 4 is in the numerator, and the 3 is in the denominator, and I'll move that x cubed down there with the 3. So this final result here is y prime equals negative 4 over 3x cubed. You attack number 32 the same way, although I'm going to simplify this. 4 divided by 2 is just 2, so this is y equals x to the negative 5. And then, so when I write this out, and you can kind of see where this is going to go, it's going to be negative 10 over x to the 6th. And this is very similar to the top row of problems. All I did is I left out the red where I write it with a negative exponent. It's negative 10x to the negative 6, but we move that down to negative 10 over x to the 6th. Okay, finally, number 33, we will rewrite it as negative 5 over 2. That's the coefficient. And then the power of x is x to the negative 3. It's x to the negative 3 because it started out in the denominator. When I multiply these, let me do an intermediate step in red here. Y prime is going to be positive 15 over 2, and then I'll have x to the negative 4. And I'm going to move that x to the negative 4 down with the 2. So in my final form, I'll have y prime equals 15 over 2x to the 4th. And hopefully this cleared up the process for working through these 9 problems. This is part of the back page of our Lots of Power Rule Practice worksheet. I'm going to cut this video off here. It's long enough for now, but if you have more questions, please feel free to ask. I love just talking to an iPad doing math. That's supposed to be funny. It's one of those Tuesdays. Take care, everyone.